if it's okay, we should start very fast to do the today job. Okay, am I audible there?
Yes, sir.
Yes, sir.
Okay, good. Just wait for 1 minute that I can run the system. Roy, you please give me the feedback. If it's okay, I start.
It's okay, sir.
Okay, good. Okay, well, can you see the PPT, please?
Yes,
Yes,
sir.
sir.
Okay, good. Today talk it's about some practical points regarding the Arduino Uno, as well as maybe if we can have time, we can speak about one nice simulator that I call it Tinkercad, and maybe we will run the first program on that, which is mainly rest of your task should conduct based on this Tinkercad as well as Protos software. Let us first discuss regarding some theoretical part of today lecture. Then after that, we will talk regarding the practical part. It means that today we also have some practical points that we will review together and may learn lots of things about this nice Arduino board. Anyway, okay. We saw that the target of our lectures is working on one specific board of Arduino that we call it Uno, and especially we are working on revision 3. Let us first of all see what is this Uno and what the difference between revision 3 and R3 type. R3 type about Arduino has this structure compared to the previous version of Arduino, especially Arduino Uno. We can say that this microcontroller is from the face, it's not much more different. I mean that if you want to check the Arduino R3 as well as suppose Arduino the previous version, from physical part it's not changed. Then why they call it R3? This is the question that today we are going to study about. First of all, this type of Arduino which use the DIP ICs, this type we call it deep or DIP part. Nowadays they are found very rarely, but still they are available. And mainly they are use the SMD type. For students who don't know, these type of ICs like these, we call it SMD type, and this type we call it DIP or deep type. Okay. What a difference is that if you want to remove this IC, it's simply you can do with the deep one. But for the SMD parts, it's difficult to easily disconnect it from the board. In the other words, if anything happened to your boards and IC, it's difficult for you to change the IC. But for deep one, you can remove the ICs and use the new one. Let us start from this point that Arduino Uno is one of the most used and documented board, which is more famous in Arduino family's board. And it's greater choice for Arduino as it's relatively cheap and very easy to set up, and it's thoughts the board you can play with. Let me tell you that there is no difficulty for any of Arduino board to install, but okay, Uno is the cheapest one we can accept. In nice things in the Arduino Uno is that this type of board can use as the programmer for other Arduino board. What I mean that suppose if today you decide to make your own Arduino board, simply you can do. Then how you should use the bootloader for the Arduino. With the help of Uno board, you can do and program the IC and then put it on the chipset. This is the most significant things about Arduino Uno that I can tell you. And the next thing is that Uno in Italian means one, and mainly it's released on IDE 1 number 1. And the latest one of this series of board is R3, which released in 2011, which is the third revision of the Arduino board. Mainly what they have done, they changed the microcontroller to 328P model of the Arduino. And what is the P diagram for this review the most significant part of Arduino Uno. First is that the controller is 328 and operating voltage is 5 volt. Input voltage is 7 to 12 volt. As I tell you, don't use this much. Try to use maximum 9 volts because the fake board that we have will damage soon. Input voltage of 6 to 20 volts that never use more than 12 volts also. Digital pins, we know that we have 40 pins, analog pin 6. Nice thing is that you should remember that don't take the current more than 40 milliampere from IO pins. And from the port that we have the voltage of 3.3, we should not go more than 50 milliampere. One thing which is more important here is that you have the flash RAM size of 32 KB, and from that part, 0.5 KB will use by the bootloader, and SRAM of 2 KB you have. Okay. Then you have the EPRAM or E2P RAM of 1 KB with the microcontroller 328 and clock speed of 60 megahertz. As all the Arduino board, you have one LED which is built on the Arduino and it's physically connected to the pin number 30. Length and width of the Arduino Uno, it's not important, but maybe for the persons who have the limitation for the size, they can see. And even the weight is 25 grams. Let us review something about this microcontroller because mainly what this Uno build before that was based on Atmega 16U. Then what the difference between this microcontroller and the recent one that they put, I mean 328P microcontroller is something that I mentioned in this slide. This 328 as a brain of the Arduino has the high performance and it has the 8 bit RISC-based microcontroller, which is capable for executing some powerful instruction. 6QU is take care of USB connection and IC/SP bootloader here as the second chips that they put there. And IO pins number, as we know, pin number 0 to 13. This is the digital pins and some PWM pin that we have. And as already you can see the sign there, I mean the pin number 3, 5, 6, 9, 10, and 11. 6 analog pins from pin number A0 to A5 that we have. Then about the power system, you have some parts which can provide the power for you. One is from USB, one is from this jack, adapter jack. You have power in parts with the specific ground, and you have some power out of 5 and 3 volt output. Never try to give the 5 volts directly or any other voltage from these pins, means that power out pin. And also remember the Arduino I/O ref, which will give the voltage reference for the microcontroller operator. And I advise you that never touch even this point, even in the just use it in the some specific project. About the memory, you should know that Atmega 328 has the 32 KB of flash memory, and as I say that it has a 2 KB of SRAM and 1 KB of E2P RAM. If you want to look to our own board regarding the communication point of view, you have 3 types of communication here, communication protocol here. One is the UART, which we'll use with the RX and TX part, pin number 0 and pin number 1 with the serial communication that we will review it in our course. I2C, which as you remember, when we discussed regarding the embedded systems communication protocol, we said that in I2C you need SCL and SDA pins as the clock signal and data signal. These are available on pin number A4 and A5, and easily you can communicate with it. These 2 pins are not external pin available in ONO for I2C, and in a copy of pins of A4 and A5. The next communication protocol is SPI type, which in that you can use pin number 11 and pin number 12, pin number 13, stand for MOSI or master out slave in, MISO as the master in slave out, and SCK as the serial clock, which are pin 11, 12, and 13. And the clock parts regarding the SCK pin, synchronization can be provided by this protocol. But one nice thing is that along with these pins that you can directly use with the pin, there is some specific place here on the Arduino Uno that we call it ICSP header. In that part, you can easily access this pinout in the one specific place. It's good for the developer that they can use this part. I don't know that we have time to check the I2C or SPI. I will try to give some example at least for you to have the some practice with these 2 parts also. But previous semester we didn't teach. This is not even difficult. You can learn simply. The clock for the Arduino Uno R3 is 60 megahertz, and they make it a little bit fast. And why chip of the Arduino running at 60 megahertz when it can run on 20 megahertz also? The reason is that because the first Arduino, when they provide, they use the Atmega 8, which is can run maximum on 60 megahertz. And when the chip again upgrade, they wanted to make them board speed compatible. Then Arduino is not really intended for the fast processing. It's only 8-bit processor, and that is why they rely just on 60 megahertz. Otherwise, 328 can run on 20 megahertz, but now they still keep it little bit slower because 60 megahertz also it's quite fine for the doing the project with Arduino board. Some other feature from um, Arduino Uno is that it has some reset switch. It has the LED on board, as we said, power LED to indicate the power, and two LED which do the identification for TX and RX on the Arduino port. That was very brief about Arduino Uno R3, which is the recent one. Previous time we reviewed some clips about the Arduino and IDE. Already I uploaded on the MOOC in the practical section. You can see that part. But now, very fast, I show you two boards of Ono and Mega that you can watch them and see the difference between Ono and Mega. Let us then see this video that I take. As you will see, this is the Ono board with the DIP and R3. This is the part that you can use for programming, and you use the USB part. The next part is the adapter jacks, and here DIP digital pins that you can see, as well as the analog one pins and regulated voltage. Here, suppose you can see this one. You can see the crystal that they put, and what I mentioned with my pen is the analog pins from A0 to A4. These pins are voltage pins from different voltage like 5 volts and 3.3 and some ground, which is very useful to run some limited module for your project. But you should be careful when you use it that don't take much more current from them when you are using them. From the back side also you can see the pins are going out. That is why we advise never use the Arduino boards on some metal sheets or any place, any conductive place. And here, suppose you can even check that they say that Uno R3 means that the model boards that I show you here. Even you can check that factor regarding the map of the Arduino. Everything is exactly based on the standard, but just what's the different? Different is this point. Let me show you. Yes. You can see this regulator is also in the golden type, but 1000% this board is not original and it's fake. Yes. Then let's continue talking about the board. The next board that I wanted to show you here is the Mega, which is my favorite board, and I have done lots of project based on this. This is that ICSP part, about the SPI part that I tell you. This is pin LED which is connected to pin number 13, which is RX and TX indicator, which is already connected to pin number 0 and 11. I should tell you that in Mega you have 4 serial port available. As you will see, you can have about 55 or 52 digital pins. You have 15 analog pins here, And rest of the things is very similar to Ono. Suppose the crystal, which is 60 megahertz, the USB and adapter jacks, they are same. This is also USB programmer chips, 6U. Then again you can see, but the main difference is that here in Mega, let me come back. Pin from 1 to 30, all of them can provide the PWM. It's not like Uno that some pin can do. Here, all of them can do. And you can see the digital pin, see pin 53, like that, as well as the other parts of the Arduino board. Suppose the programming can be from here, LED turn on, and also the other parts of the Arduino board. Then from the backside, if you want to see the backside of our mega board, you will see that again all the pins are out, and you should avoid to use these boards on some metal or conductive place like this. Let me see. Here, so for example, I show you the voltage. Again, you will see the V in 5 volts, 3.3, and the indicator for the pin number 30, RXT, as well as the other parts. Suppose again we have reset switch, ICSP, analog pin, and digital one. And I thought that maybe you will not have chance to see the Mega now. That is why I provide this video for you. And okay, that was my fault. Then the next practical things that I wanted to talk today, it's about LED blinking that I prefer to discuss on the next part of our lectures. But I don't know how much time we have till end of lecture. Answer, please.
I think it's about 1 hour.
Okay, 1 hour for 2 lectures, you say. Okay, good, no problem. Then we can continue, no problem. Okay, that was the practical point 2. Let us see the practical point 3. That
it's your display.
Yes, wait. I should change the PPTs and then you can watch it proper. Yes. Now I think you can see. Can you see this, please?
Yes, sir.
Okay, good. The third practical things that we should know that now we learn something about Arduino. We review the Arduino Uno specification, especially R3. We talk regarding the IDE and how we should install it. Now, very fast, I just teach you something regarding running the first program on Arduino, but discussing regarding all this, maybe we'll do for the next lecture, because today especially I want to talk about the simulator part, but I will tell you how to run the first program on the Arduino. Then this is the points that we are going to learn today is about programming the Arduino and first LED blink. First of all, you should know that when you install the Arduino Uno, Arduino IDE, when you click on the this point, this point, this IDE can be open. But there is one nice point in IDE, especially Arduino IDE, which we call it example. And you know that one method of learning is that you can see what other people will do or learn from the examples of other person, some example that they put. And as we know, the Arduino is rely on the open source method of programming. Then maybe using the other program and also watching the other program will teach us more things. And now, because we don't have that much skill to do the programming, we are going to visit one example. How we can reach the examples? Very simple. Just from File, Example, Basic, and Blink. This is the place that you can reach to the first example of Arduino, and we will analyze it, but later we will have lots of talk about this example. Okay, let us see. When you open that example, you will see this figure, which in that some parts are comment. From up to this part, these are the comments that they put. And really, it's not doing anything. This is some description, but which can help you and give you some information. Let us see. Suppose what they said that on Ono Mega 0 digital pin number 3 and on NKR 1000 on pin 6, LED built-in is set to correct LED pin independence on which board is used. It means that for omega and 0, the word of the LED built-in is directly connected by hardware to pin number 30, and for NKR thousands, it's on pin number 6. If you want to know what pin on your board LED is connected to your Arduino model, check the technical specification. It's not bad, and there is some modified type. Okay. Then from these parts, what we need to know that which project they want to know. They want to turn on an LED for 1 second and then off for 1 second again. Means that we blinking the LED or make it on and off. Okay. Otherwise, from the coding point of view, there is nothing there. Then, as we discussed, in Arduino coding, you have two parts. One is that setup, another one is loop. We said that in setup, the fixed term or some fixed initialization will do. What is the then main initialization for us for this specific project is that we should say what is the LED built-in pin rule. We know that it's output because it should turning on and off an LED. Then we define that this statement or syntax of pin mode and LED built in as output. Then the next part of our program is loop, which in that first we should make one pin high or make it 1 and then wait and then again make it low. Same thing we have the digital right when we want to make some pin on or off, and which pin LED built-in pin, and then we make it high, then wait for 1 second and then again make that pin low and then delay 1 second. All this process is intended to turn on and then turn off an LED. Let me show you how it will do. Very simple like this. See the LED? LED is here. Yes, LED is turned on. Again, we can even review the parts that we need for programming. It's this just pin mode, which will tell me that which pin and what is the rule. Then digital write, which I will say which value I want to write on that pin. Uh, Maybe some of you say that can we change the pin? Yes, if you change the pin like this is my video. Simply you can add to another pins and also run it, means that make it on or off. Very simple. To make your LED on and off, just you need one resistor and use another pin. Suppose I think here I use pin number around 11, like 11 or 10. I don't remember. But just I changed this word. LED built-in, I put it in the pins that I want. Let us see some more demos on Arduino Uno that we have done again. Yes, this is the Arduino Uno. And I do something that it's not good. You don't do it. We can directly connect the LED to the Arduino, but this is the original one. You don't try to use it. One pin should be ground, and another pin should be the should be connected to the LED pin. About this hardware, we will talk later. You will see here that now what we have done the blinking, but define the LED pin as 30, and then we say that pin mode LED is the pin number 30. We define it as output in the setup, and then in the loop one, we do the digital write. Let's make it high 1 second, make it low 1 second. Very simple, and we specify exactly the pin number 13 as the output of our project. Now let us go a little bit fast. First we'll compile. You will see that when you do the compile job, it says that done compile, and then we'll go for programming, and then after programming you can see that the LED is turned on and off. Maybe one more demo just about the same job to remember the codes. You know that we have two parts of setup and loop in Arduino world. In Arduino you can use, first you should specify the pin mode, and from now even still I didn't enter the coding part, but see, when you type the correct word, then the color of the syntax will be changed. See, when I do the pin mode, see, pin mode. When the syntax is correct, then the color will change. Remember this point. It will help you to, even when you do the coding, have less error. Then in pin mode, I should say pin number 13 as output, nothing else. And in the void loop, I should do the digital write to this pin, make it high, wait for some minutes, or calling the delay process, and then make it low, again some delay process. Let us see, digital write, and then pin number 13 high. I wait for 500, not 1000. It was that half of 1 second, 500 millisecond then, and again low and delay 500. Okay, how I should program is like this. You should connect to the Arduino board, After connect to Arduino board and do the programming, is compiling and then sending there, you will see that LED start to blinking very fast. You can play with this job, with this delay time, make it faster. See, LED is very fast. Even you can put it on another LED, take one LED and one resistor and directly connect to the pin. This is what should be this value of resistor? It should be 330 or 1K is in the safer side for you. Simply can do it. Yes, connect suppose to pin number 6, 7, and then other pin should connect to the ground. As you will see, you have ground there. Go and connect. And now run it. The loops is complete now. Just you should change the pin number. Yes. Now we use pin 8. Then all the tasks should be on pin number 8. We could define this pin as LED at the top, and just if you do like that, just to change one place. But now because we directly specify the pin, you will see that they change it. Okay, now you will see that it's blinking. Change the time. Equal on, equal off. Now. Even you can use two LED and do the setting. I will go a little bit fast because I have some specific lecture for you about it. What we can do, we can just define another pin and then load the program, and when suppose one is on, another one can turn off. Just see the performance. Like this we can work. Okay, now I stop. We can have rest for around 5-10 minutes and come back. Is there a question now? Any question?
No,
Not
sir.
right now, sir. No.
No, sir.
Okay, take rest. We will come back soon. Okay. Okay. One thing. I think you should turn on your camera. I forgot to do the attendance. Please turn on your camera very fast. Sorry. Fast.
Sir, I am present. Faisal, my camera, don't give.
Okay, Faisal. Okay.
Thank you, sir.
Fast. Jihad remained. Let me also come. Jihad and Moshi. Very good. Roy, what's going on there? This is lecture.
I think they are making chai, sir.
Yes, I know. They are at the party. They are not serious with the lecture. Anyway, take rest. We will come back soon.
You can turn off your camera.
Yes, you can turn off. Have to join fast.
Yes, sir.
Okay, good, good. Okay, as the next part, I should tell you one thing. You know, today's world is not like that, that we can accessing all the hardware that we need. What I mean that if we want to test any program, the perfect way is to using the real hardware. But some nice things, especially for Arduino, they have done, and that is how we can connect or using some simulator which acting as the real hardware for us. And with the help of this simulator, you can replicate your job there and see the result. I just want to say that if you use the simulator, you don't need the real hardware. But I can say that if you are using this simulator or any simulator, you can have less problem when you're running the uh, program on your real platform. Then one of the recent simulator that these days people are work with that is Tinkercad, which it's introduced recently for the Arduino. I mean, recently, these 5 years, 4 years back, and it's very powerful and can help you to do the project. By using this Tinkercad, we are doing our task in this lectures or series of lectures, and this is the main simulator that we are using. Besides, I will teach you Pro Tools also to do the work, but I want that you mainly focus on Tinkercad as the simulator. Okay. What we are going to speak today, it's about Arduino simulation by using Tinkercad. We will review some ID important part and what is the difference between extension files in Arduino board. Maybe the second lecture of today will take more time, but please let me to finish today because we need it for rest of our lectures. Okay. Tinkercad, known as the free and online 3D modeling program that run in the web browsers, announced for its simplicity and ease of use. Since this software is available from 2011, it's become more popular platform for creating the models of 3D printing, as well as entry-level introduction to constructive solid geometry in school. If we want to know the brief about this software, we can say that The owner of software is Autodesk. The URL is tinkercad.com. It's commercial. It needs registration. It's launched in 2011 and it's written in WebGL and JavaScript. Except the URL job, none of this information is useful. I think the main things that you should know is that the URL is tinkercad.com. Then, what did happen? Next level of Tinkercad, after doing the successful designing for 3D printer and so on, some job like that, is that they come to the Arduino world and use as the expansion to include the circuits in its design capability. They call it Tinkercad circuits, and this brings the whole new side to Tinkercad and revolving around simulating circuits with Arduino. You know the Arduino, it's the open source. Now Tinkercad is also some open source and on the web simulator. Then it's become the nice combination between these two gadgets, we can say. But why Tinkercad circuit we should use? Because it's very simple and it's online 3D design and printing app for everyone. And simply when there are some targets like that, you design the what we can say, the hardware part, for example, any shape that you want with 3D printing, and then do the programming with Arduino and do the combination at the end. Means that mainly their aim is that to make some process or finish the process of having the product very fast, but in the simulation job. Okay. Some benefit from this Tinkercad is that it's online, or you don't need to install anything in any of PC. Just you will go to the URL. It's open source, no need for any license for everyone. It's free for everyone. It's simulator. He offered a good interface for designing and simulating a project, and he is better than FreeSync. FreeSync also is one simulator that before Tinkercad people will use, but there are some package problem and some lack of components that they need. But now in Tinkercad they start to remove that limitation. What the circuits add to the Tinkercad is that it's also known as the extra combine. Those two words, CAD environment now comes with the circuits components, and it means that 3D modeling now can have the combination with the circuits. As I tell you, the main aim is that suppose you want to make some toys like that and do the programming for that, you can do all of them in one package and or one simulator like this and enjoy it. Then maybe the main aim is that you can do the simulator for doing from zero to end of the jobs, from designing the interface as well as the circuit parts and finish the jobs. Which components we can take? In design suits, there are lots of components. I think the hardware that you can see here, it's exactly more than what we are going to use. And it's sufficient even for us. We can use them. Some other components are still there, but mainly we are working with this part. How we can enter? We should go for tinkercad.com and select the components area. You will see that this is my account in Tinkercad, and easily you can even enter to that and using the process. Let us see the parts. It's very simple. First is name of your project, that it can be any name. Some editing tools like rotating, some recycle bin, undo, redo, note, and visible or unvisibly. This is your profile part. This is the programming simulation that you can do the start simulation, export, and code that we will talk about it. And next part is the components area that you can see. This we call, and this main page here, we call it building area. Components area are on the right side of your screen, and you will see the group of drag and drop electronics components. On top, you can search and filter even some parts that you want, and then easily you can catch them. Everything from LED to ICs and a few instrument tools is available in this part. Building area, or this part, is the open building area, is where you design your creation and you can drop your components here. The next part is programming code part, that you can do it here. Now something nice will come to picture. You have two options for programming. One is blocks, same as what I teach you in MIT app course. One is blocks plus text. Okay. What I learned is that when they introduced the Tinkercad for me around 2 years back, like that, and that time I was not aware about it. They say that they put these blocks that permit the persons who don't know the C language use that. And even for persons who know the C language also, or whatever you will do with Arduino IDE, you can copy and paste it for the code section and see. We will see this part later. But here, suppose what we have done, we make one Ono, we have one LEDs, and then we are going to suppose replicate the LED projector. Let us see. What currently we have about Arduino, we just have Arduino Oro R3 and 18E. It may be extend later, but anyway, Oro R3 is quite fine and suitable for us. We can use it. And 18E is also more limited and minimized Arduino part that maybe you are not using or using. It's not important in this level. Later, if you want, you can continue to working with the 18E also controllers, means that from Arduino family there. And nice thing is that whatever you have in Arduino IDE, you can directly copy paste it here and enjoy. Well, for the coding or programming part, what they have done as default is that you can use it by default by code blocks. But if you have the real codes also, you can use it. And nice thing is that you can translate the actual codes and blocks and block codes together with the help of the Arduino, with the help of Tinkercad. I mean that maybe you can write you can write the codes in the C language, and then you can use Tinkercad and convert your codes to the blocks and vice versa. Okay, this is the nice things. Even somehow, if you think that coding is simple, you can do the coding. Now you know the blocks also. You can do the blocks part also. Some limited tools we have, something like rotate, something like trash, something like redo, undo, notes, and visibly and undo visible part, which are quite useful and not more than this you need when you work with the Tinkercad. Next part is that this part that I said, that you can do the coding and start simulation and export it. And the nice thing is that you can use the share part. This share part, if you use, your project will be shared with other Tinkercad user, and they also can see what you have done. You also can use the project, means that some ready project that they have done, and you can enjoy their code also. Anyway, how to get started is that you can go to the Tinkercad and set up a free account, mainly by Gmail. It's quite fun. I check in China also. Last semester, Chinese students work with any account, with Yahoo or any other which don't need the VPN. You can use it for students who are out of China and don't have Gmail limitation. Also, it's work, but mainly the what we can say the Gmail. It's quite nice. Have the quite nice collaboration with the Tinkercad if you want to work. Then you will go for join now and then do the sign in part through that. Then it will ask you about your Gmail or any other address. Maybe you have signed in with Apple also. On a student join your class also, you can have some even teaching methods there. But now I don't want that you interact with that part. From here, choose the Google and then do the signing at the next step. And second is that enter your password. Finish. You will enter simply to the Tinkercad words, and this page will open for you. Okay. When this page is open, then what you can see the 3D design, circuits, code blocks, lessons, join class, project. Nice. There are some good option here that you can do. Mainly you will go for the create new design, okay, after selecting the circuit type. Even you can work on your profile, put your name, some little biography about yourself, and then go for the design and see other person design, what they have done. Nice things they have done here. You can see their project, you can check their project, you can check their codes, everything is free, okay. And then suppose you can try some circuits. After selecting the circuits and create the new circuits, you can enter to that. Let us see this on the movie. It may be better through the clips, real clips. Same job I have done. Enter after doing the registration. One tool we have now in the Tinkercad. And now you will see that this page will be open. Yes, this is the profile file from me. Then these are the different parts. Code blocks, lessons. Then maybe you can arrange the class. You can see some 3D design that people will do with 3D printer, something like this. It's nice, I think. Then there are some block Tinkercad also that people will share their project there. Suppose you see, this is some project that people share there. You can go and learn, do the learning part. Hmm? Starters, learners, projects, like that. There are the various parts in Tinkercad that you can use. And so many parts. And truly speaking, I didn't touch all of them. I just concentrate on Arduino part and 3D printer part. But I saw that there are so many things there. And this data, it's around, I think, 4 months back. Huh? And now I don't know. Maybe there are lots of change there. We should sit together and see that. Okay, maybe they are. Suppose I want to see that which sensors they have. I put show me sensors in the secret part. That it shows the projects which are based on sensors. And you see, they are the nice lab, the virtual lab that now you can use it and you can enjoy it free. Yeah, that was one a small tour in Tinkercad. How to creating the account is also very simple for person that who don't want to use their Gmail or the person who have the limitation for VPN problem or any other restriction. You can simply create the account like this, add your country, birthday, next, and then go to the Tinkercad secret spot, click on 3D design, and select whatever you want. Let us see, suppose demo number 1 that I have done. I will go to the secret part. Take little bit time. Yes, it's open. Then from that, let us see what I have done. You will see the part, then the code part, start simulation, export, share in the Windows. Then maybe we can have, this is a filter for the parts, for the components. You can suppose select some specific one if you want, or just type the name of that, suppose Arduino or any other things that you want. See, when you can see it, you have Arduino LED. Suppose I will take one resistor, number one LED, then I will take one battery first to check the polarity of my LED. Yes, I take one breadboard, but I think that was not good. I should remove one, yes. Okay, and then put the LEDs there on my breadboard or dot matrix board. This board they call it breadboard. Okay, I can change the color of LED. Wow, see, yellow, red, blue, as I want, and I can put the name for that. Suppose blinker. A resistor value also I can change. Suppose 10K or 1K is enough. I can put 10K. Suppose should take it down. Yes, put it here because the breadboard's dot are connect. Yes, this also I can do simply there. Now what I need, I should take the battery to test the polarity of that 9-volt battery. Just positive and negative polarity of the battery I can take and connect. Simple. Yes, now it's connected. Okay. Now Now, after this connection, what I need? I need to start the simulation. See, LED is run. Means that the polarity is okay. I can make it orange, I can make it yellow, green, blue, as I want. The different color can come to picture, even red one. I advise you to do the same job. First project should be just run one LED with the batteries. And then because I didn't select the microcontrollers, then the code part is not open. Now when I select the Arduino, suppose Uno, if I touch the code part, then it will going to do that. See, make it little bit small. Now I have two battery. I don't want. I just want one battery and one Arduino Uno. Yes, now when I click the code part, I will see some blocks or blocks and text or just text will happen. I rely on the text or already when you run the Uno, this LED program in the block is there. You can even check. Let me see. Yes, demo 2. Go a little bit fast. Select the LEDs. I think 1 and 2 is same. Okay, then in the code part, I should copy paste the code. Some student last semester tell me that we have problem to log in the China. Then this is the proof that I put because that time I was not in China. I just ask, I think Roy, to enter to the web page and check it for me and give the clips. This is the clips that Roy give me, and it means that there is no limitation for the persons inside or outside of China. That is why I put it log in China. Simply you can add. Besides also, I ask one more question that one more student that she also check, and now I'm sure that it's 100% work in China. Okay. Now how to start working with Tinkercad? Very simple. Step number 1 is that after creating your free Autodesk account or log into the Tinkercad, you will be met with the project selection page and click the circuits button on the left like this, and then create the new circuits and then select the component, something like Arduino R3 or any other that you want. Select some breadboard, or you can or you cannot, but it's better that you have the breadboard and put it there. Then for the code part, you can use the block as well as writing the code. If you want to do the coding part also, it's very simple. You can just copy paste the example that I show you from IDE and just put it here with the help of one resistor and one LED. The resistor can be 220 ohm above. 1K is safer side. You can put it there and just copy paste the code here and run or start the simulation. Let us see this job. Let me show you the again the project. I take LED and resistor, then I take the breadboard, then do the connections. I will go a little bit fast because this job we saw. Okay. Then I take one Arduino board. I just rotate it to have the better view. Okay. I need one pin to give on and off from Arduino and one ground from Arduino pins. Simply go here and connect to the ground. Yeah, that ground is connected. Now give the pulse. LED color is green. Then now I should go for the code section, copy paste the code there. And then you will see that I copy paste the same code that I had. And you will see that suppose I now specify the pin number 12, and you will see LED is turning on and off. Very simple. What I have done, nothing, just specify the pin 12 as the output and then run it. See, on, off, like that. Simple. One other example also we can have, this job we can do it later, but you can see the example. With serial monitoring, when I teach you this thing, you can add one pin to the serial, one potentiometer to serial, and do the reading of serial communication. See, the value can be, so here, even it can have the plot here. We will review this on our lectures later also. Just I wanted to show you that even serial monitoring is available. Now, what we can have as the output, we can have the PNG export and share also. And some project like this, you can export that other people will come and use it. There you go. And even you can explore some possible projects like what you want to do is that other people also do it. You can take their project and also use their project, their codes, um, and it's not maybe good for doing the task, but for doing the project, it's good. Let us see one official clip from Tinkercad. Similar what you said I made. This is exactly the blinking LED. See what they said from Tinkercad. They said that just you need the USB board as well as Arduino Uno and then connect to the LED part. And then after simulation, you will see that the LED is turned on and off. We need two pins, one is ground, one is the digital pin that LED is connected to that. The act of this resistor we will talk next lecture, but it's just to limit the currents. $220 it's okay, but 1K I like 1K resistor generally. Simply you can connect like this. Something that we will study later is that for LED, it's not like resistor that you can use any polarity. We have anode and cathode, and we should connect it based on our logic to the resistor. Anyway, this is the place of pin number 13 that you can see on the Arduino side. And then see, this is the code blocks part. In code blocks part, let me stop it. You will see that it's very simple. This is the title block comments is that pin 13 of Arduino. You can have some comment. You can set the built in LED high, wait for 1 second, make it have some comment, make it low and wait for some seconds. See here. And then we will replicate the 1 second job here, 1 second on, 1 second off. If we want to go for the code section, we can select the code bar or convert it from the block to the text also. See. This will help the small children to learn how to do the C language, but for you, no need to do that. But if you want to compare, you will see that this part is the comment part, and the void setup is the second part that you say with the pin mode 13 as the output, and then again you have the comment here as you will see, then you will make it high, delay, again low, and then delay. Let me go a little bit fast to save time. Then the next thing is that the circuits also you can find it there, but no need to do that. I prefer that you do it then. Also, the same thing that I tell you, you can copy paste from Arduino IDE and put it in the file, or you can even load. Just connect the USB cable, go to the board, select the words, and do the serial settings, then load it. You can do something like this that we will do next lecture. We are just talking for the LED parts also. This you can find on YouTube. I also take it from YouTube, but that was some, we can say, official video about the Tinkercad. That is why I put it as the web page. Okay. Now for the first part, let us stop for the Tinkercad and tell me, do you have any question?
Not yet.
Right now, no,
No.
sir.
No, sir.
Okay. Okay. Then let me finish the rest of today's lectures very fast. That we are reviewing the IDE important parts and what are the different file extensions that we have. I think I just need 5 to 10 minutes to finish everything about this part. Ready?
Yes, sir.
Okay, let us see. As I think most of you now install the IDE, we have some important part on that. First is the verify, which is has this symbol. When you written your code and press this part, it will verify and see that you have any error in your program or not. If verification process pass, you can use the second icon as it's going to upload on your Arduino. If you want to create the new scratch, a new program, you can use the third button. If you want to open the existing scratch or built-in example, you can use this. Or if you want to use this to save the current sketch, you will use this. And for seeing the serial communications value or having any type of serial communication, you can use this magnifier. This part, I can say, is the most important part which we can have in our ID of the Arduino. Next blank one or white one is the coder parts. This will give some message regarding the command that we want, and this dark page or blank part will give us some information, like if you have any error, it can come here. If it cannot establish the proper communication with the Arduino board, it will return there for you. Or if there are some any error, we can say, or any mismatch with your hardware part, you can see it here. But the main important part is here that always it's small, but you can check. Two things will written here. One is the name of the board that you use. Another one is the name of COM port that you are using. Have it in your mind that these 2 points is more important, because most of the Arduino user have this problem and they cannot select the proper COM ports on the boards. Then again, I mentioned here, suppose here there was some error that you will see, and see when you will do the compiling, you can see the word of done compiling, which will give the message from Arduino to you that is done. Okay, next again, let us see the Arduino blinking program that we run it here. In that, when you load the program, proper on Arduino, you can have this message of done uploading, and your program can work on the real hardware part. That was most important part. But when you make the Arduino program, you may have some extension that is not bad to know them and review them. Which extension file will create by the IDE for you? First one is .ino, which is the main extension of your script, and your primary sketch file must be an .ino file, name same as the directory that is located in. You can create additional INO file in your sketch name however you like. Before completion, all additional .ino file are appended to the primary sketch file, and they are copied in ascending order based on file name, and all are run through the standard process of gathering, includes all generating prototypes. Remember, then the first is INO. What are the next is .pde, .hccp, and .c. These are the other extension file that you can see. .pde is the default extension for the sketch written for Arduino IDE number 1. And if you use that, means that version of Arduino IDE or greater, you should rename it to INO or .pd. Also, you can, this advice that you make your IDE always update. .h extension is for the header files, something like the library that we have in C language. And mainly if your sketch use the set of constant that multiple .ccp or .ino file will use, you can create a single location of your common variables, and functions that are defined can be in different .ccp files, can have the declaration in the header with the extension of .h. And .ccp file is as the extension of C++, and in some case or sometimes that a sketch become quite large, and you can utilize a .ccp file to separate the sections of your code. And definition inside the .ccp file that you want to access elsewhere should have the declaration inside the .h file. This type of header will allow your sketch to include the header and its functionality, and also An important point is your .ccp file do not go through the IDE pre-compilation modification and therefore has no prototype generated. For more information about it, you can check the Arduino webpage. The next extension is .c, and if you want to write your code pure in the C, you can make .c and also run it there. That was useful information about extension of Arduino outcome IDE, which sometimes will help people when they have the problem to identify that this file will be open in Arduino IDE or not, and will help the developer more. As task number 7, I want that you log into the Tinkercad and repeat the blink example and send it in the PPT form in the task section of MOOC. No need to send on email part. Just send on the MOOC system. Maybe some person I will tell them to send me through email, but most of you I want that you please send on the MOOC system. I will define the task and then you can send it there. Now we can stop. It's okay for today. If you don't have any question, please turn on your camera.